Hello everyone, this is Super CEO. Welcome to my first video ever. So before I start, let me throw this in requested by Cambridge. So that's a little disclaimer saying that all the work here is really produced by me only, got nothing to do with Cambridge. All right, so now my first topic that I've chosen to do the video on is continuous random variable. Now I'm going by extension 1 textbook, but this topic, the continuous random variable, is also a common topic with a 2-unit or advanced mathematics. So if you're using 2-unit textbook, the same questions are found in chapter 10 in section B. That's the first section that I'll go by. And if you're using extension 1 textbook, it is section 16B. Exactly the same questions. There's only you will see later on that the different questions, the questions are different in challenge section or the enrichment section. So we'll worry about that when we get to that stage. Okay, so the very first question, I'm going to skip section A because it's the discrete random variable. So I'm just going to solely focus on the continuous variable stuff. All right, so excuse me. Question 1 is like that. And here we go. Here's my actual solutions. All right, so question 1, what you're asked to do is find this little f of x with the given domain from 0 to 2 is actually a PDF. That is probability density function. So two things that you have to do. First, in this domain, you have to show that the given function is positive. Well, by definition, it's pretty obvious. It's half, so it doesn't matter what x value you've got. It's always going to be half within this given domain. So it's going to be positive. So the first condition ticked off. The second one is now, that's what I mean by that, by definition. So now the second one is to show that the integration of that little f of x for this domain, so the definite integral between 0 and 2, has to be, at the end of the day, giving you 1. Well, that's basic integration exercise. So from 0 to 2, half dx. So that little integrand is half. So it's going to be half x outside the integration. Evaluate it from 0 to 2, then you get 1. So, second condition ticked off. Therefore, this is indeed a probability density function. Moving on to C, notice I'm skipping B because it's very similar to the one that I had. C, different function given there with a different domain. Now, it's always helpful if you can always draw a little diagram that illustrates this. So here, this is a nice linear function going through the origin, but between x equals 4 and 10, it doesn't go through the origin because the main starts at 4, finishes at 10. So if you do that, the corresponding y values are 2 on 21, 5 on 21. And this is an increasing function because the gradient is 1 on 42. So it's going up the hill. So it's positive. So the least value is 2 on 21. So therefore, within that domain, the function here, x on 42, is always positive. So the first condition ticked off. The second one, as usual, show that the definite integral from 4 to 10 is, you need to check off that whether that is actually giving you 1. Again, perform your usual integration technique. So then that's giving you that. So 84 over 84 will give you 1. So therefore, this is also the probability density function. All right, moving on to the next part, which is question 2. So let's have a look at question 2 and let's see what it's asking you to do. So again, giving you what you need to do to prove a function is PDF, the probability density function, and you're given all these 6 different cases to see that whether that is a PDF or not. Now, again, I'm not going to do every single one of them, but here I've got A, B, and C, D, and E. Well, looks like yeah, well, I've done all 6 of them, so, all right, well, your lucky day. This is your lucky day. All right, so question 1. Now, the other thing that I forgot to mention is that you actually have to, on top of that, you have to actually find the mode, if it is indeed a PDF. All right, so question 1, as usual, you do that, show that it's positive. There we go. 3x squared, well, x squared, we all know it's always positive, or at least 0 for any value of x. So therefore between even 0 and 1, it's still going to be non-negative. And you multiply that by 3, so therefore this is always greater than or equal to 0. All right, next one is the integral, the definite integral in that domain, 0 to 1. Again, simple integration calculations to do, and then substitution gives you 1. So beautiful. This is PDF. Therefore, I can now go on and find out the mode. Remember, the mode is the actual x value that gives the function little f of x the maximum. So this is 3x squared is an increasing function in that domain. So the y value gets maximized at the largest x value that you've got, which is x equals 1. So therefore the mode is 1, okay? Not 3. Remember, the mode is the actual x value that maximizes the y value. All right, part B. The given function now is x on 4. Domain is 1 to 5. Again, x on 4 is greater than or equal to 0. In fact, it's actually strictly greater than 0 because it's the least value is a quarter there. Okay, this is a linear function increasing, so it's 1 on 4 is the least value, so it's, yep, so the first condition ticked off. The next one is the definite integral from 1 to 5. Then you get that, 25 take away 1 over 8, which is 3. Hence, it's not equal to 1, hence, not a PDF. Therefore, you don't need to worry about finding the mode. C, again, unfortunately, this turns out to be not a PDF, but let's see why that's the case. Fx is decreasing. Why? Because here the gradient is negative 2 on 3. So it's decreasing. Therefore, the maximum value is at the first x value, and the minimum is at 3. Now, f equals 0, giving you 4 and 3, that's positive. But again, f of 3, if you substitute it properly, then you get minus 2 on 3. So again, it violates the first condition, being that f of x has to be positive no matter what, as long as the x lies between 0 and 3. But that fails to be so, hence, which therefore doesn't satisfy the first condition, hence not a PDF. You don't even need to do the integral part because the first condition is failed. Hence, don't need to worry about finding the mode. All right, D. This is an interesting one. F of x equals n plus 1 times x to the n. Now, I think the textbook didn't quite actually mention what n has to be, but we're going to assume that n is a positive integer. So there we go. That's, I made a little statement there. All right. So if that's the case, n plus 1, that's going to be even more positive because n is positive. So n plus adding 1 in the word is going to be, it's going to make it even more positive. And that's my way of saying end. X to the n is always greater than 0 for all values of x that's positive real value. Now, why is it the positive real value? Because the domain is between 0 and 1. So, I mean, you can just focus on it, but we know that x is positive, the base is positive, then the power of it, as long as the power is positive integer, then that's going to be always positive. So if that is true for all positive real x, then it has to be true for x value between 0 and 1. So we can confidently say that this is always greater than 0. So the first condition is met. And now the definite integral, the domain is 0 to 1. So if you perform that integral, then that's x to the n plus 1 substituted, then you get 1. So that's now a perfect PDF. Hence, we're able to find the mode. Now, we know that this is increasing because lies between 0 and 1, and n is a positive integer. So this is increasing. Therefore, because the function is increasing, the mode occurs when x is the largest within the given domain, which is 1. So the mode is 1. There we go. Part E, the little fx is now half sine x. Domain goes from 0 to pi, and sketch that. Then you get this. All right, so the half of the full cycle of the sine function. So from this graph, we can clearly see that that is greater than or equal to 0 for the given domain. All right, and therefore now we can move on to the definite integral. If you do that, remember the primitive of sine function is the negative of the cosine, and that's negative half. Evaluated from 0 to pi. Then now I do a little tricky. If I don't want to deal with the negative, so what I do is I drop the negative sign and then swap that order. Okay, so that's the little technique that you do. Or you can just, if you don't like that technique, you can just substitute it as usual. Just be careful with the negative sign though. And if you do that, recalling all the exact values from the trig functions, then you get that. So therefore, this is indeed a PDF. Hence, we should be able to find out the mode. Now here, the y value maximizes at x equals pi on 2. So the mode is now pi on 2. Okay, now the last question of the question 2 is this. So now the little f of x is given, that little number is actually 2 squared. All right, so 3x squared. Now I've factorized it. Okay, why? Because it's easier for me to sketch this. So the x-intercept is 0 and -3 on 2, but the domain only goes from 0 to 2. All right. Now notice this is just out of scale because that's 2/3 and that's 2, so it looks the same, but that's why I just mentioned it as out of scale. But clearly we can see that within the given domain, the function itself is positive or at least non-negative. So the first condition ticked off, and then the definite integral, perform it, then you get that, and nicely turns out to be 1. So therefore this is PDF, and therefore we should now go ahead and find out the mode. Now this is an increasing, so therefore the mode, the maximum value of this function occurs at the last value of the x domain, so which is 2. So the mode has to be 2. All right, so that does about it. That concludes my first video. Thanks for watching, and I'll see you guys next time.